Welcome, students. Today we're going to be talking about solving equations that involve the absolute value. Now, the absolute value is just these two lines, and we'll stick anything in between them. So like the absolute value of -3. When I draw these by hand, usually one thing I'll do so that they don't look like ones is I'll draw them bigger than what I'm drawing the other numbers as. Another way you can kind of distinguish the way you're writing an absolute value, you can also make it thicker. And that's another way to kind of differentiate those symbols from just the number 1 so that this doesn't look like 1 minus 31. We make them longer and thicker. And now it looks like absolute value of -3. Okay. Anyways, absolute value is there to say what is the distance between this number and 0. So how far away is a -3 from 0? It's 3 away. One of the effects of asking this type of question is that all negatives simply become positive. We'd never say a distance in terms of negatives, or at least not usually. I don't say I've got -5 feet of rope. I just ran -3 miles. That sounds weird. We talk about distances in the positive. And so that's usually what will happen. Now, this leads us to certain properties. Property number 1, the absolute value of a number is always greater than or equal to 0. Or in other words, it's going to be positive. The absolute value of a product of two numbers is the same as the absolute value of the product of the absolute value of each number. So in other words, absolute value of A times B is equal to the absolute value of A times by the absolute value of B. Number 3, the absolute value of any number is going to be equal to the absolute value of its negative. In other words, we're just going to get the positive version of A in both cases. All right, in the fourth one, this is similar to the second one that we saw, but the absolute value of A divided by B is equal to the absolute value of A divided by the absolute value of B. One little caveat there, B cannot equal 0, and that's because we should never divide by a 0. It doesn't make sense. All right, solving absolute value equations. So if you've been given some equation, kind of looks like this. It doesn't always have to look exactly like this, but this will give you a good idea. The absolute value of ax plus b is equal to c, where c is greater than 0. Now that's an important remark that they're making, and we're going to need to use that fact later on, is that what it's equal to has to be positive. Because if it was negative, there's no way of answering this, because anything coming out of the absolute value is going to become a positive. And if it has to equal a negative, well, there's just no answer to that. There's no way of finding that. But if C was a positive, we can solve this in two ways. By getting AX plus B is equal to C, and solving the equation. Notice everything stays the same. AX plus B equals, and then the one thing that changed is on the side opposite from the absolute value, it changed to a negative. That's the big change. So absolute value equations are going to have two answers. Now, to show why that is in a more simple fashion, let's take away all the fluff, and let's say absolute value of x is equal to something like 2. Now, what are the possible answers that would make this true? Well, if x equaled 2, that would work. Absolute value of 2 would equal 2. But there's one more. And that would be that if x equaled a -2. Okay, so absolute value of -2 would also equal a 2. That's all that is happening here. Okay, so we need to see when ax plus b is equal to a c. We also need to know when ax plus b is equal to a negative c, because then when we've got negative c inside of those absolute values, it'll change to a positive c. Okay, so we're always going to get those two. Here they talk about what I just said, that if c is less than a 0, there is no solution, because our absolute value cannot give a negative number. All right, so let's look at solving a few real quick. First problem, we've got absolute value of x minus 4 is equal to a 6. First thing I'm going to do, separate it into two different equations. First one, x minus 4 is equal to 6. The second one, x minus 4 is equal to a negative 6. Because if this equals a negative 6 in here, absolute value of that will give us the positive. So now, beginning to do my work, I'm going to add a 4 to both sides so that I can get my x alone. Negative 4 plus 4 is 0, and x is equal to 10. Okay. Next one, the work is going to look pretty similar. Once again, I still need to get x alone. I'm going to add by a 4. It's made slightly trickier by the fact that we've got a negative over there. Not too much more difficult. Negative 4 plus 4 is still 0. X minus a 0 is just x. And then negative 6 plus 4 will be a negative 2. And there's our two answers. X can be a 10 and a negative 2. Those are the two solutions. Okay, and we could try them out by putting them in. If we put in the negative 2 minus 4 is negative 6. Absolute value of negative 6 is 6. 10 minus 4 is 6. Absolute value of 6 is 6. And that's just a quick way of checking. Just go ahead, plug the number back in. Does it come out the way you expect? All right, once again, separate it out into two. 3x plus 1 will equal the negative 5, I've left it unchanged, and 3x plus 1 is equal to positive 5. Now I've changed the sign on that constant. So now we begin the solving process. I'm going to minus a 1 from each side of this. Negative or plus 1 minus 1 is just a 0. 3x plus 0 is just 3x. So 3x is equal to negative 6. Divide both sides by 3, and we're going to get x is equal to a negative 2. All right, again, we'll minus a 1 from each side, and we'll get 3x because that became 0. 3x plus 0 is just 3x. 5 minus 1 is equal to 4. Divide by 3. 3 divided by 3 is 1. 1x is equal to 4/3. All right, and there we've got it. Solving equations with absolute value. In this next problem, notice what has made this one more difficult than the other ones, or looking different than the other ones. And it's just that minus 10. That's really the only thing, is we've got this number outside of the absolute value, but that's still on the same side. So the way I'm going to fix this is I'm just going to add it so that now I don't have that number over there. So I'll still have my absolute value, 3x plus 9, but negative 10 plus 10 was a 0. Anything minus 0 is still itself. So that portion remained unchanged. And then negative 4 plus 10 is just a 6. Okay, now this problem looks exactly like the ones above. So our next step, we'll separate it in two. So we'll have a 3x plus 9 is equal to a 6, and another one that is 3x plus 9 is equal to negative 6. All right, get that constant on the other side first. So 9 minus 9 is 0. 3x plus 0 is 3x. 6 minus 9 is a negative 3. Now we'll divide both sides by 3, and we will have, because 3 divided by 3 is 1, we have 1x, and negative 3 divided by 3 is negative 1. So there's our first answer. And it repeats. Basically, it's going to be the exact same work on both sides. You'll get a slightly different answer because one was negative and one was positive. But the work is going to look pretty much the same. Divide by 3, and we will get x is equal to a negative 5. So there's my two solutions. So what we learned from this is if you see something with your absolute value, get it to the other side first before you begin. That's it. Isolate it. That's what that word was all about. Isolate it first. Okay, once it's on the other side, once the absolute value is alone on its side, then you're ready to begin by splitting it into its two different equations. All right, now let's talk about using absolute value to find the least and greatest value. And we're going to use this form of it. So when you've got a least and greatest, so here's my least, here's my greatest. Sweet. Right there, I'm just going to put, that's my halfway point. All right. Now, this could be something like you're doing a woodworking project. Now, when you're working with wood, you want to be fairly precise. That being said, you probably don't have to be as precise working with wood and getting everything cut specifically as maybe someone working with a microchip. Their precision has to be much greater. But let's say I want to cut something and it needs to be about 3.5 inches. But if it's a 1/16 of an inch off in either direction, it's not going to damage our build. Okay, we're going to be just fine. Now that's probably a bit too big, but that's what my brain came up with. I would probably want greater accuracy than that myself. But that's kind of the idea, that this halfway point, this is what we're aiming at, but we could have a little bit below, a little bit above, but we then get this range of that's the least possible and that's the greatest possible. Anything outside of that and the cut was bad and we don't want to use it. Okay. That's going to show up in this equation where h, that represents our halfway point. D, that's standing for the distance from that halfway point. So if here's my halfway point, then I've got the distance below and then the distance above. How much wiggle room do I have in there? Okay. And x is going to be the way we solve for how much that wiggle room is. Okay, or no, that's our distance. Let me kind of demonstrate it. So let's talk about this next problem. The average cheerleading routine should be about 4.5 minutes. Now, that's our desired area. So that's kind of our halfway point, is our 4.5. There is a half minute of wiggle room. So we could go about 0.5 above that and we could go about 0.5 below that. Write a single absolute value equation that's going to represent the minimum and maximum lengths of the routine. So x is the length of our routine in this situation. And we want to know how far away is it from our halfway point, okay? How far off is this cheerleader's routine from that 4.5 minutes? Now that's their goal. They're okay to go a little bit above or a little bit below, but not by too much. And how much above and below are they able to go? By about 1/2 minute. Okay. And here's how this equation would then separate and work out. We'd separate that out. X minus 4.5 is equal to a 0.5. X minus 4.5 is equal to a 0.5. Now, the thing about subtraction is subtraction tells us the distance. So we're trying to figure out how long can the routine be. So if we subtract this from this, it'll tell us how far apart in minutes is the actual routine from the desired amount. And we're going to solve for this. So if we do that, adding the 4.5 to each side of this, we get x is equal to, first, 5 minutes. Okay, now this is going to be our maximum. That's the longest routine possible, would be 5 minutes. If we took this other one, did the same thing, we're going to get x is equal to 4 minutes. And that's our minimum. But notice that subtraction. It was giving us the distance. And when we separated them, this gave us the distance. It combined the distance between the routine and our max distance, and we got our maximum. Okay, and then over here we got our minimum. All right, next, what if there are two absolute value equations? If the absolute values of two algebraic equations are equal, then they must either be equal to each other or be opposites of each other. All right, so solving an equation with two absolute values. So going back to the statement, if the absolute value of two algebraic expressions are equal, so we've got absolute value of two algebraic expressions, they must either be equal to each other. Notice the first one. They just set them equal. Or they must be opposites of each other. Now, if they're opposites, that's like a positive and a negative. So it pretty much looks like what we've already done. Okay, there's not going to be a huge change here. So this is going to split into two equations, one in which they are the same, and one in which they are opposites. And then we begin solving the equations. Oh, and I nearly made a mistake. So I was focusing in on that number, but first thing I want to focus in on, let's get that variable on only one side. So I'm going to minus x from each side. Okay, now x minus x, that's just going to leave us with a 0 over here. We'll have 2x's minus 4. Add the 4. We'll have 2x is equal to 4. I'm going to need a little extra space. So I'm going to move you over here. Okay, so then 2x is equal to 4, divide by 2, and x is equal to 2. Once again, and I made the same mistake again. I want to get that variable on only one side first. Now, I could add that 4 first. I guess it doesn't make much of a difference, but out of pure habit, and I think it's a really good habit to have, I do prefer to deal with the variable being on both sides immediately to get rid of that problem. I cannot solve an equation unless the variable is only on one side. And so before I do anything else, I tend to try to solve that problem. So we get 2x. Oops, I made a mistake. Sorry, when I added the x, 3x plus x, that should have given me 4x's. Got too busy talking, and I can't talk, or I can't talk and walk at the same time. All right, so 4x equals 4. So 4x equals 4, we will divide by 4, and x will equal 1. And we found our two solutions. All right, so let's do this again. We're going to have where the two are the same. Now, this was 2 times all of that. Since we're now removing the absolute values, I need something to replace them as a bracket, so I'm putting in parentheses to still show that that 2 still needed to multiply to both of those. We're now just signifying it with parentheses. All right, and then I would have over here where it's going to be the opposites, 4x minus 10 is equal to negative 2 times, and now where they are opposites. Okay, all right, so as I do this, we're going to need to do some simplifying steps first. So 4x minus 10 is going to be equal to 6x plus 2. Let's now get that variable on only one side. Really important to me. So we'll have negative 10 is equal to 2x plus 2 minus the 2 from each side. I'm writing kind of small, but I'm running out of room. 2x is equal to negative 12 divide by our 2, and our x will equal negative 6. All right, over here, similar first step, we're going to multiply that negative 2 through, so we'll have negative 6x minus 2. This time, since that's already lower than the negative 4, I'm going to eliminate this one. The reason I did that is just because rather than eliminating the 4 like I did before, because negative 6 is lower than a 4, if I do it this way, then I can have equations that only deal with positive coefficients. So notice the number in front of x is a positive. Over here, the number in front of x was a positive. It doesn't have to be that way. I can divide by negatives. I'm not afraid of it. That being said, life is easier when you deal with less negatives. So I avoid it when I can. Okay. Then we do our division. Divide by 10. and x is equal to an 8/10, which is a 4/5. Okay. All right, so we just solved with two different absolute values. Let's talk about something called an extraneous solution. So when you solve an absolute value equation, it is possible for a solution to be extraneous. An extraneous solution is an apparent solution that needs to be rejected because it doesn't satisfy the original equation. Now, when we say it doesn't satisfy the original equation, what we're trying to say is it makes them not equal. Even though we did all this math and we solved it, if we plug it back in, it's not actually equal. It doesn't actually work. So we're going to check for extraneous solutions, and it's going to be a fairly simple process. But first, we got to solve this. So 2x plus 12 is equal to 4x, where they are the same. 2x plus 12 is equal to negative 4x, where they are opposites. And once again, I keep on forgetting. Let's eliminate that so that we got the variable on only one side. So I'm going to have 12 is equal to 2x divide by 2, and x is equal to a 6. All right, so here's our first solution. Next, once again, I want to get the variable on only one side. I'm going to switch it this time because that 4 is a negative. So I'm going to add things so that I get nice positive numbers. 6x plus a 12 is equal to a 0 minus 12. And we get 6x is equal to negative 12. Divide by 6. X is equal to a negative 2. Now we're going to quickly check both of those answers because we just got two answers, but maybe one of them is extraneous. Now, the only time you need to check for extraneous solutions is if you've got the variable on both sides of the equals. Okay, in those situations, you should probably do a quick check for extraneous solutions. Okay, all right, so let's see what happens. Let's plug in the 6 to begin with. So absolute value of 2 times 6 plus 12. Notice I'm just writing the equation as it was. The big difference is I'm replacing x with the number. All right, well, 2 times 6 is 12. 12 plus 12 is 24. So this will be the absolute value of 24 is equal to 4 times 6 is 24. Well, absolute value of 24 does equal 24. That one checks out. So 6 checks out. If we do it with negative 2, so 2 times negative 2 plus 12 is equal to 4 times negative 2. All right, 2 times negative 2 is going to be negative 4. Negative 4 plus 12 is going to give us a negative 8. So we're going to have absolute value of negative 8, or sorry, positive 8. What am I saying? Negative 4 plus 12 is 8. And then over here, 4 times negative 2 will give us a negative 8. Now, at first that looks good, but then we remember absolute value always will give a positive number. This cannot be true because this demands that our absolute value give us a negative number. That absolute value of 8 turns to a negative 8? No. So x is equal to negative 2 is what we call an extraneous solution. It looked like a solution, but it doesn't satisfy the original equation. It doesn't make the original equation true. Now let's look at it with this one that has variable on both sides and two absolute values and see what issues arise out of this one as we check our answers. Step 1, we're going to solve for when they're the same. Step 2, we're going to solve for when they're opposites. Okay, always the same and opposite, because remember, it's as simple as what we talked about at the beginning. How can the absolute value of x equal a 2? Well, when an x is a 2, when they're the same, and when x is the opposite of a 2. When it's a negative 2, then they'll also be equal. And that's really all that's happening there with the same and the opposite. All right, so first, let's go ahead to get that variable on only one side. X minus x is 0, x minus x is 0, 5 equals 11. Well, that doesn't help. There's no solution that's going to come out of this equation. It's just not going to work. So in order to find any solution, we're going to have to turn to the next one, and hopefully it can give us something more useful. So first I distributed my minus through. So then x plus 5 is, and now we're going to get the variable on only one side. Because that x is a negative, this time I'll add it, which will make it so that over here it doesn't eliminate, and we get 2x plus 5. And then we get negative 11 minus 5. 2x is equal to negative 16. Divide by 2. Then x is equal to a negative 8. Okay. So this was one in which we just didn't find two solutions. Not that we found an extraneous solution, but we found a situation that just was not going to work. There's no way for both of these to come out the same. Okay? All right. I hope this helps. Good luck.